In this video, we are going to see the last important part of a video camera, the sensor. The sensor transform the optical energy into electrical one. So transduce optical images into electrical signals. For this purpose, for this phenomenon of transduction, several technologies can be used. Photovoltaic devices, photoemissive devices, photoconductive devices. Regarding regarding the technology used for the sensors included in the cameras, mainly two technologies, CCD and CMOS, are mainly based on the photoconductive principle. This consists in that certain material becomes more electrically conductive because they can absorb the external electromagnetic radiation, such as visible light, ultraviolet light, or even infrared light or gamma radiation. Nowadays, CMOS technology are prevalent over the CCD technology. Different advantages of CMOS technology justify this fact. First, CMOS technology allows a random and simpler access to any photocell. Unlike the CCD technology, which uh, all the data image, all the picture elements of that sensor needs to be downloaded and later they can be discarded. But CMOS allows just to access to the specific elements in our sensor that we want to. This allows us to increase, for example, the effective frame acquisition, because instead of acquiring all the picture elements, we are just focused on certain picture elements. Another advantage of the CMOS is that all the electronics can be integrated in the same chip, accelerating, speeding up the production and having an impact in the final price of this technology. CMOS also has a lower consumption in comparison with CCD. Also related to the first point, the random and simple access, uh, we can make more advanced tasks using CMOS technology, like selecting the region of interest for our image. Also, we can set up or make a more advanced setup of the shutter and other elements. The last interesting advantage is that with the CMOS, we can simultaneously use three different acquisition modes, unlike CCD that only have two. CCD have high sensitivity mode and also low sensitivity mode, but CMOS technology allows an additional one, the hybrid mode, that is very useful for high dynamic range applications. For example, if we have this scene in which we want to acquire one image that are capturing part of an indoor environment and part of an outdoor environment corresponding to these windows, using the long integration time mode related to the low sensitivity, we are extending the period, the time in which the camera is admitting the incoming light. So that extension is useful because in the indoor image area, there are low quantity of light and we need more light. We need to collect light during more time for produce a correct image, so that the sensor, the picture elements of corresponding to the sensor are correctly excited. But those regions that have a great amount of light are just saturated, burned. On the other hand, if we use the short integration mode or high sensitivity or low sensitivity, the time for capturing, for admitting the light is short. That allows to create a correct image in those areas. In this case, corresponding to the window, we can see the exterior of the window where there is a great quantity of light. But as you can see in the indoor part of the image, where the light is in comparison lower, the sensor, the image, the region are quite dark because the sensor hasn't enough incoming and model light to correlate excite the sensor. So in CCD, you have to choose between one of these modes of operation. But in CMOS, we have a third mode in which we can combine both. For some regions, we can put the sensor in short integration time, and for other regions, we can put the sensor into low integration time, allowing in general a higher quality image because we are increasing the effective dynamic range acquisition of the sensor. This video is the last of this session. The next session will be given as usual presentially by the Professor Luis Salgado.